Your last activity was to find the constant velocity of a toy car on a flat horizontal surface. Of course, if it's on a flat horizontal surface, it's a motorized toy car, then presumably it's going to go at a constant velocity. You can see this one called Acceleration Lab, and you can see the way the apparatus is set up is that the cart, not a motorized cart, just a cart, an engineless cart, is placed on an incline, which means then we let it go, it's going to accelerate, it's going to speed up as it goes toward the bottom of the incline. This activity is going to be to find, essentially, to find the acceleration of this cart as it goes down that incline. Now you're going to need to do a little bit more for this activity than you did for the last one, starting with the apparatus/materials. I don't have the apparatus and materials listed here. I've just got a picture of it. I think, and it's not mandatory, but I think a picture is a good way to start when you're listing your materials. Why? Not because it's sufficient in itself, but because if you take a picture with your phone and then insert it right into your document, you can't forget anything, right? You can't forget a material. It's pretty hard to forget that you used a track when you can see a picture of a track right in your document. So what do we use here? We use a dynamics track. Some of them will be metal, some of them will be wood. It doesn't matter which one you use, but just make sure you use the corresponding cart. Some of the carts you're going to see are clearly designed for the metal tracks. Some of them are clearly designed for the wooden tracks. You'll figure that out when you see it. You're also going to use your motion sensor again. The same motion sensor that you used last time. In addition to the motion sensor, you're going to use the AirLink apparatus, which looks a little bit different than this. This is an older version of it. You guys know what it looks like, right? Because you guys used it for your last constant velocity lab. Okay. What's not in there that you're going to use? That's a pretty poor picture of an iPhone or whatever phone you're using. But in the end, you need to collect the AirLink apparatus, which is this thing, to your iPhone via Bluetooth so you can download the data. Make sense? You're also going to need a procedure. What's the procedure look like here? The good news is it's a pretty straightforward procedure. Okay, set this up. Don't just say set up apparatus. Okay, that's not detailed enough. Having said that, I also don't need to see crazy detail like I broke my pencil lead, so I went and sharpened my pencil. I don't care about that. Well, I do. I feel sorry for you if you broke your pencil lead. But I don't care enough that you need to include it in your lab write-up, okay? You need to say something like, you put a track on an incline, used a couple of books, or whatever the case may be, to create an incline, set up the track on the incline. Okay, you set up the motion sensor at the back of the track and connected the motion sensor via the via the AirLink apparatus to your iPhone. You put the cart on the track, you turn it on, and you let it go. Make sure you mention that you downloaded the data, and then you do your thing. Does that make sense? Something like that kind of detail. Again, I don't need the fact that, on the first trial, I bent over with my knee on the floor and got dirt on my knee, so I wiped it off with my hand, and then I repeated the trial. I don't care about that kind of detail, but you do need to basically put enough detail that somebody could repeat the experiment with the apparatus and with a little bit of physics knowledge. Somebody could repeat the experiment with your procedure. Does that make sense? Could somebody do this experiment? Could somebody from another class come in and do this experiment simply based on your procedure that you listed? Then, of course, you need data. What's the data going to look like? Your data is going to have 3 columns: time, position, and velocity. But the good news is you're not going to have to type anything out because you're going to do the same thing as you did last time. You're going to email the data to yourself from the SparkView app, and then it's going to have a whole bunch more columns. You guys know that, right? You're going to delete all those other columns. So you're going to be left with only 3 columns. Last time it was 2. Okay, this time it's going to be 3. Time, position, and velocity. That's going to be in a spreadsheet. Now, from that spreadsheet, you can copy it into your document that you're going to actually end up submitting to me. And you can also do what you need to do in that spreadsheet as far as graphs, which includes a couple of different things. You need to plot a position time graph. In other words, you need to plot a graph using these two columns. Okay, that's analysis question number 1. Okay, I want you to describe the motion referencing that graph. In other words, I know that this is constant velocity because the position time graph showed a straight line. Or I know that it's acceleration because the position time graph was curved, or whatever the case may be, okay? The second one says calculate the acceleration of the object using the velocity time graph. So the second graph you're going to plot is the third column and the first column. Velocity versus time. And of course, you're going to use Google Sheets to calculate the slope of that graph for you, which is going to tell you what the acceleration is. You don't need to show your work for this. You need to just state the acceleration. But I need to see that it's the same acceleration that your graph, your velocity versus time graph, right over here showed you. You guys remember how to display that, right? How to display the slope? The slope of that graph is your acceleration in this case, and you're going to want to have the same value right here as you list right here in number 2 for your acceleration. Finally, the third question, we're going to actually scrap. So you're plotting 2 graphs here, not 3. The first graph is position versus time, and you're not doing anything with that other than looking at the shape and identifying what motion you have referencing that graph. The second graph is velocity versus time. You are going to do something with that. You're going to draw that line of best fit. You're going to calculate the slope, or at least Google Sheets will calculate the slope for you. And then you're going to answer question number 2, which is, what is the acceleration? Then you're going to have a conclusion. Your conclusion is going to be, basically, take a look at the analysis questions. Your conclusion is essentially going to be the motion of this object was constant velocity, or the motion of this object was accelerated motion based on the shape of the position time graph. The value of the acceleration was blank based on the slope of the velocity time graph. And then, of course, you're going to identify sources of error. 2 or 3 good sources of error, and then the corresponding suggestions for improvement for next time. All right? If you're wondering if one of your sources of error was good enough the last time, okay, have a look. Okay, have a look at the lab that I sent back to you. If you're wondering if your conclusion was good enough last time, have a look at the lab that I sent back to you earlier today. All right? And of course, if you have any questions, then by all means you can ask those questions.